Hello guys. So I am going to start a series on machine learning algorithms and this is my very first class. So welcome to the session on linear regression. Today's agenda is we are going to understand what do we mean by linear regression, what is the difference in simple linear regression and multiple linear regression, why is it important? What are the applications of linear regression and what are the assumptions of linear regression that one should keep in mind while implementing the linear regression model? And we will touch the topics of cost function and gradient descent. We are just going to understand what is it, but not going to study in detail in this class because they are a very large topic. So we will discuss cost function and gradient descent in the following classes. So let's start with linear regression. What is it? What is it? Like, what do we mean by linear regression? So it is nothing. It just tells the relationship between two or more variables. So what is the relationship between them? Suppose we have to predict price of the house. So price of the house will depend on area of the house, number of bedrooms, number of bathrooms, number of floors in the house, neighborhood. So all the so price of the house will depend on all these factors, or we can say all these variables. And so that's why the price of the house is dependent on these variables. That's why we call it a dependent variable. And area of the house, number of bedrooms, these variables will help in predicting the price of the house. That's why we call them independent variables. So linear regression is statistical method used to model the relationship between two or more variables. Term linear stands for the best fit line. Have studied about a straight line equation, which is y equals to mx plus c, where m is our slope of a line and c is the intercept of the line. So similarly, this is just a straight line. Okay, and beta naught is the intercept and beta 1 is the slope of a line. So what does the slope of a line means? So it is saying that if there is a 1 unit change in x variable, what would be the change in y? Best fit straight line that predicts y based on the value of x. So based on the value of our area and the coefficients of that area, that what is the strength of that area that in predicting the value of y. So before uh, coming to the assumptions, let's also discuss that why is it important. So linear regression model is important in predictive modeling. So in predictive modeling, we used to predict future outcomes based on the historical data. So and also understanding the relationships. So it linear regression helps us in understanding how changes in one variable affect another. And it also provides insights into the strength and direction of the relationship between the variables, that if our x is increasing, our y is also increasing. If our x is decreasing, y is with increasing or decreasing. So it tells the direction and strength of the relationship between the variables as well. So what are some common applications on linear regression? So for example, let's say predicting economic indicators like GDP based on the factors like inflation and unemployment. If we are considering the marketing strategies, so what would be the how we can, so it will help us in predicting sales based on the advertising expenditure. And if in the healthcare sector, we can predict patient outcomes, or the what where does that patient stands in terms of health based on various health metrics. uh, these are like sugar or BP, all these metrics and so on. So let's discuss about the assumptions of linear regression. So before uh, going into the assumptions, let's discuss uh, what happens when we implement linear regression model. So when we train linear regression or say multiple regression model, the coefficient during the training, what model learns? So model learns the value of the parameters or say coefficients, which is intercept and slope. So during the training of a model, model learns the value of slope and intercept. Okay, so uh, so this happens when we implement linear regression, when we train linear regression model or multiple linear regression model. So let's just deep dive in the assumptions of linear regression. There are some assumptions on linear regressions. I have listed five assumptions, but there can be some more as well. But these are the five important assumptions that one should keep in mind while implementing linear regression. So the very first one is that linearity, the relationship between x and y. So the relationship between x and y should be linear. That means it should have a straight line. Okay, so I'm not talking about polynomial regression or other types of regression here. I'm just talking about a linear regression. Okay, and I have already explained you the term linear means. What does it mean? Okay, so if what happens if you fit a linear model to a non-linear data set, the regression algorithm would fail to capture the trend mathematically, because if it's a polynomial regression problem, then it would fail to capture the trend. So, thus resulting in an inefficient model. Also, this will result in erroneous predictions on an unseen data set. Unseen data set means new data set when we have to predict some value for the given number of independent variables. The next assumption is independence, which is self-explanatory. Like observations are independent of each other. They should be random in nature. They should be independent. The third assumption is no or little multicollinearity. Either no multicollinearity or little multicollinearity is allowed, very little. So what happens? What is it? So what do we mean by multicollinearity? Basically, independent variables which are x variables. So when independent variables are correlated and can be predicted from one another. So mm, for example, we have we have some we have two variables, and they have the name of the both the variables are different, but the values are almost similar. Okay, so in that sense, these two variables are completely or highly correlated. So we don't want to include these variable in the model training. So either we can remove one of the variable if they are completely same, or otherwise we have to handle them separately. So what happens if we have multicollinearity? So this affects the model interpretability, but not the model performance, because it doesn't impact R square. Instead, R square increases with more number of variables. So if we increase the number of variables, our value of the R square keeps on increasing. That's why it is important to consider adjusted R square as well while evaluating the model, because adjusted R square penalize the extra number of variables. Okay, so multicollinearity hides the individual effect of the independent variable. So basically, uh, if we if we are going to predict y, and our x1 and x2 are highly correlated, then we don't know that we can't interpret that either x1 is impacting more on the value of y, or x2. So we it because they would be autocorrelated. They can't explain the variability. Okay, so this is multicollinearity. And next is homoscedasticity. Then what is homoscedasticity? The variance of residuals. What are residuals? So residuals are the error terms which I am going to explain in this class only. So these are the error terms. So what is the error term? What is error? So when we are predicting a value, suppose the actual price uh, of a t-shirt, let's say, actual price of a t-shirt is 200 rupees, and my model has predicted the price of a t-shirt, say, 250. So there is a difference of 50 rupees in the price, in predicted value as well as the actual value. So that is the error, that 50 rupees is the error. So we are talking about the same error. So the variance of those errors is constant across all levels of x. So this should follow, a linear regression model should follow this assumption. We can't we can't deal with heteroscedasticity. So it should not have heteroscedasticity, which is caused due to outliers basically in the data set, and have unequal scattered distribution of residuals. So this I am going to explain you with a graph. Don't worry about that. And so let's understand the difference in the homoscedasticity and heteroscedasticity. So this is how it looks. So in case of homoscedasticity, we have read that the variance of the residual is constant across all the levels of x. So across all the levels of x, we can see this distribution of all the terms, all the observations, and all so this is like this is not following any pattern. So it is errors having a random nature. Or what is error? Like suppose this is our point and this is our predicted line. So this is the error, and every error is randomly distributed. But here, in case of heteroscedasticity, we can see from the graph that it is following a pattern. So it is following a cone, we can say cone or fan shaped scatter plot. So this is the sign of heteroscedasticity in the data set, which can be fixed using a log transformation, which we are going to study in further classes. Then next next assumption is normality, which is again related to residuals, that error terms are normally distributed. So what do we mean by error terms are normally distributed? So these are these red lines. These red lines are the distribution of error terms. So these red lines should not look like these red lines which are in the heterozygosity. So it should look, the distribution of these lines should be same. The spread should be same. Okay, so yeah, that's all about the assumptions. So let's again get back to the linear regression and its understanding. So this is, I have already explained you about the straight line equation, which is y equals to mx plus c. Here c is the intercept, which is beta naught, and m is the slope, which is beta 1, and x is the independent variable, and how change in x will impact change in y, and our y is dependent variable. So there can be different best fits, different straight lines. Okay, so there can be, while training a, why do we train a model? We train a model so that our model can learn best values of slope and intercept to get the best fitted line. So in the data set, we can have this line as well, this line as well, this line as well. But the most appropriate value of slope and intercept will like decide that which one is the best fitted line out of these three different lines. Okay. So if we have trained three different models, the model one will get this as a best fit line, model two will get this as the best fit line, and model three will get this as a best fit line. So based on the performance metrics or evaluation metrics, we will decide that which one is the most appropriate model, or we can say most accurate model, which is giving the high accuracy out of these three models. So this is the regression equation for multiple linear regression model. This beta naught is the intercept here. Beta 1 is the coefficient of x1 variable. Beta 2 be the coefficient of x2 variable, and so on. So for example, in case of predicting price of a house, or price of a house, then our x1 could be area, x2 could be number of bedrooms, x3 could be number of bathrooms, xn could be neighborhood. So this the when we create a scatter plot of our variable x, how does it look? It looks like this. Okay, and so it has some relationship between, there is some relationship between x and y. And what is that relationship? Is it a linear relationship, polynomial relationship, or increasing relationship, positive relationship, negative relationship? What kind of relationship we have between x and y, that we get to know from the best fit line. So this is the best fit line. This blue line, we call it a best fit line. And here we have this black point, our actual data point, and this best fit line will have a predicted value of y. So there is a difference in actual value and the predicted value, they are not same. Ideally they should be same. That's why we find out the best fit line so that we can minimize these errors. So, so the difference between these two values, the actual value and the predicted value, is the error term, or we can say it is the residual term. So this is the error term. This is nothing but the difference between the actual value and the predicted value. And here our goal, while training the model, our goal is to minimize this error. So so one second. Hmm. So here our goal is to fit the best fit line by minimizing the error in the predicted and actual points. So how does the model, how we can write the model equation, that is f w comma b of x equals to wx plus b, because this is, you can see it is very similar or same as a straight line equation. This is for a linear regression, one variable. And where w and b are the parameters, means w is our intercept, sorry, b is our intercept and w is our slope. So these are the parameters that model learn the value of these two parameters while training. And how we get the value of these parameters? So basically when we train the model learns the value of these two parameters, and using this cost function, our objective is, this cost function is nothing but the, we can also say loss function. We say loss function when we have only uh, one observation, but when we have m number of observation, then we say cost function. So so this is nothing but just the error average of the error, squared errors. And our objective here is to minimize this cost function. And to minimize this cost function, we use an algorithm called gradient descent. So with what happens with large amount of data and more complex ML models, and in more complex ML models, we can't manually find the best value for W and B parameters. So we want an efficient algorithm that can write in code for automatically finding the values of parameters W and B, and they give you the best fit line. So that minimizes the cost function. So this algorithm is known as gradient descent. So, so this is uh, the end of our today's session. Let me know, how do you like it? You like it or not? Do you get everything? Have you understood everything? Everything about the linear regression? What is it? What are the applications of linear regression? What are the assumptions of linear regressions? Just do let me know in the comment section, sorry. So thank you guys. Bye.